Hi everyone, and welcome to part 2 of our elemental groupings presentation. In this particular presentation, I'm going to be teaching you about the rows and columns of the periodic table and what patterns they hold. I'll also talk a little bit about the metals and non-metals and metalloids found on the periodic table as well. So let's get started with our periods or our rows. The rows of the periodic table are referred to as the periods of the periodic table. All of the elements in a period have the same number of electron shells. So the first period here, the first row, has got one shell. Hydrogen has got one electron in its outer shell, its only shell, and hydrogen is very reactive just because it does have that one electron, and it's very keen to find one more electron, so it ends up with two in its outer shell. So hydrogen will often form a bond with another hydrogen atom, forming H2. Helium, on the other end of the periodic table, helium has got two electrons in its first shell, so helium is actually stable. Helium is happy with two electrons in its outer shell, and it doesn't want to react. So we refer to helium and these elements in the 18th column here, in the 18th group, as noble gases. They're not reactive. And with helium having two electrons in its outer, well, one and only shell, it is not reactive. It's happy with just those two electrons. The second period has got two shells of electrons. The third period has got three shells, fourth period has got four shells, so on and so forth down the periodic table. So when you go to take your notes after this, just be really clear with your notations that each period, period 2, 3, 4, 5, has got the corresponding matching number of shells. Period 1 has got one shell, period 2 has got two shells, period 3 has got three shells worth of electrons. Let's take a step forward and talk about the groups or the columns of the periodic table. So it's fairly common that students confuse periods and groups. So when you go to take your study notes, do try to take extra special careful attention with differentiating between the groups and the periods and what they represent. The periods are the rows, the groups are the columns. So let's have a look at the groups now. Each column is called a group. The elements in each group have the same number of electrons in the outer shell. So that's another common area where students get a bit confused. It's the number of electrons in the outer shell. In the outer shell. They are the electrons involved in chemical bonds with other elements. So the electrons in the outer shell determine an element's reactivity. Its reactivity. Group 1 here, the alkali metals, they're highly reactive, and they're highly reactive because they've just got one electron in their outer shell, so they're really keen to get rid of that one electron so they can become more stable. So alkali metals, they're explosive in their reaction. If you throw sodium, a pure piece of sodium into water, it explodes because they're just so willing to get rid of that one electron in their outer shell. The second group, the alkaline earth metals, these metals are also very reactive. They've got two electrons in the outer shell, which they're keen to get rid of. Not quite as reactive as the alkali metals, but still very reactive. We then skip over the transitional metals, so the ones in blue, transition metals. We skip over this part of the periodic table, and we come to the other side, which contains our metalloids, other metals, and also our non-metals here. And we've got some gases too. But the 13th group, or third group, depending on which periodic table you're looking at, has got 3 electrons, 4, 5, 6, 7, 8, all the way to the end of the periodic table. So the 18th group, or the 8th group, depending on which periodic table you're looking at, are your noble gases. These elements are stable. They've got a full set of electrons in their outer shell, so they are not reactive. From neon down, they've got 8 electrons in their outer shell, so they're happy with what they have. They are stable. They want to keep 8 electrons in their outer shell, so they're not particularly reactive. The only exception is helium, which contains 2 electrons in its outer shell, and that's all it needs for it to be stable. But from neon down, we've got 8 electrons in the outer shell. They're noble gases, they're unreactive. Group 17, however, or group 7, are my halogens. Halogens have got 7 electrons in their outer shell, and they're very reactive. They're really keen to find one more electron, take one more electron from somewhere to complete their outer shell. So my halogens are very reactive, looking for that one extra electron to complete their outer shell. And when they get that electron, they form an ion, a negative ion, an anion. So these are our groups. When you go to take your notes, be careful to specify that you're skipping over the transitional metals, group 1, 2, 3, 4, 5, 6, 7, 8, all the way to the noble gases. Okay, let's keep moving forwards and have a look at some properties of the various types of elements we have on the periodic table. We'll start with metals. So metals, I've got alkali metals, earth metals here, transitional metals here as well. They are solid at room temperature, except for mercury, which is a liquid. They can be polished to produce a high shine or luster. They are good conductors of electricity and heat. They can all be beaten or bent into a variety of shapes. We say they are malleable. They can be made into a wire, and we can say this as being ductile. And they usually melt at high temperatures, with a couple of exceptions like mercury or gallium as another one. Our non-metals, which are these ones here, at room temperature, 11 of them are gases. So they also include some of these ones here as well, our other metals and metalloids here. The solid non-metals have most of the following features in common. So the solid non-metals. They cannot be polished to give a shine like metals. They're usually dull or glassy. They are brittle, which means they shatter when they are hit. They can't be bent into shape, they just break. And they are usually poor conductors of electricity and heat. They usually melt at low temperatures. Our metalloids, which are my grey ones here, okay, so along here. Some of the elements in the non-metal group look like metals. One example is silicon. While it can be polished like a metal, silicon is a poor conductor of heat and electricity and cannot be bent or made into a wire. Those elements that have features of both metals and non-metals are called metalloids, and they can exist in various forms like solids, liquids, gases as well. So they blur the line between non-metals and metals depending on what characteristics they have. There are 8 metalloids altogether: boron, silicon, arsenic, germanium, antimony, polonium, astatine, and tellurium. Noble gases on the very end here, group 18. Noble gases make up a group of chemical elements with similar properties under standard conditions. They're all odorless, colorless, monoatomic gases with very low chemical reactivity. 6 naturally occurring noble gases are helium, neon, argon, krypton, xenon, and the radioactive radon. We often use noble gases within our street lights, like you probably heard of neon lights before, and that's because when you pass electricity through these gases, the electrons get very excited and they move around and they shake and they give off light as you pass electricity, as you pass a current through the gas. And depending on which gas you have in the tube determines what color light they give off, which is pretty cool. So your neon light will give off a different color light to argon gas. And if you want to know the specifics, you can of course always Google which noble gases give off which color light when you pass electricity through them. Alkali metals we touched on before, so they're extremely reactive, very keen to get rid of that electron on the outer shell. Any of the elements, lithium, sodium, potassium, rubidium, cesium, and francium of the periodic table, they are very reactive. Okay, these ones, I would like you to do a little bit of research on your own. What was group 2 called? Okay, so can you read the periodic table, or can you remember what I mentioned before? What is group 7 or 17 called over here? Can you read the periodic table, or can you remember what I said before. What are these ones called? And finally, what are their properties? This one you may need to do a little bit of Googling to figure out. How are they a little bit different to the other elements? I spoke a little bit about the halogens and why they are reactive. What other properties do halogens have? So hit the Googles and do a little bit of independent research. Okay, from here you can move on to some private study, and there's a number of activities to do. First of all, definitely take some study notes from this PowerPoint. I've got 3 worksheets within our Teams folder. I'd like you to also read and complete pages 11 to 18 of booklet 2. Some of it is just some theory to read, and some of it is some practice questions, but just work your way through progressively through pages 11 to 18. And you can begin and complete any of these Education Perfect modules which are relevant to you. And that's it. So thank you for watching and listening. Hit the like button, hit subscribe, and I'll see you in the next episode. See you later.